Okay, here's video number 2 for today, Tuesday. I'm getting better at this online learning thing. So we're going to talk about quadratic roots today, and today is the first day we're actually going to solve a quadratic equation. So if you've ever seen an equation, maybe on PrepWorks or somewhere else where it says solve this, and it has an x squared, you're like, what? So you couldn't really divide and get x equals. So let's say you got like x squared equaled, I don't know, whatever, you wouldn't have been able to solve it other than how we're going to learn to solve it going forward now. So today is going to be the first introduction to what a solution is to a quadratic. We're gonna explore it in graph form, which I know we all love, and I personally am sick and tired of graphs, but just kidding, I love graphs. Just kidding, I hate them. So we're going to look more at graphs, and I will work out all the problems in your lesson. I want you to do homework 4, which I understand you don't want to graph, but at least try to do 4 and then all of numbers 10 through 15. There's no assignment due today. However, your Math Excel is due Friday, so make sure you get on that if you haven't already. Please do your Kahoots so you can practice more vertex form transformations. Okay, so a quadratic root is basically what a root is the point at which the parabola, and I can do points in parentheses, so the point or points at which the parabola intersects the x-axis. So this is the key word here. X-axis is where you will find your solutions to quadratic equations. So there are 4 names for an answer basically to a quadratic. They could be called a root, a zero, a solution, or just simply an x-intercept. So all 4 of those things can be used interchangeably, and you need to be aware that they all mean the same thing. So if you're looking at number of solutions, a quadratic equation can have at most 2 solutions. When I say at most, obviously that means there can be less. I said obviously, but that's not obvious because you don't know. So there can be at most 2 solutions because let me see if I can blow your mind for a second. So if we have a linear equation, so linear, an example of a linear is like y equals x plus 1. There's only one real solution to a linear equation because you get x equals. For a quadratic, y equals x squared, you can have at most 2 solutions. For a cubic function, y equals x to the third, you can have at most, how many you think? If linear is 1 solution and the degree of this variable is 1, if a quadratic can have at most 2 solutions and the degree is 2, cubic should have how many? 3, because the degree is 3. Okay, so if you are given, and I think on PrepWorks, maybe you might have a problem that says, how many solutions would this equation or function have? And it was a cube. It would be 3 because a solution is basically where that graph hits the x-intercept or the x-axis. So a cubic function can have at most 3. A quadratic can have at most 2, and a linear obviously can have at most 1. All right. So these are what your graphs could look like, and obviously these aren't the only things that they could look like if they have 2 solutions. So the parabola crosses 2 points on the x-axis, either going, going up, opening upwards, or downwards. It could have 1 solution where just the vertex touches the x-axis, or it could even have no solution where none of the parabola touches the x-axis. Okay, so again, a root, a zero, a solution, or an x-intercept is all meaning the answer to a quadratic equation. So just like in systems, just like in every other thing, there's always a couple of ways to find answers, and as always, the way that is the least likable way is always first. So we're going to go through and graph more quadratic equations so I can show you what it means to find the root. So it's asking you to find the solutions of the following quadratic equations by graphing. These are your directions. So again, the first thing we know what to do when we're starting to graph is to find the vertex. In order to find the vertex in something that's not in vertex form, aka standard form like this is to find your axis of symmetry. So that means that this is going to be -4, over 2 times 1, which equals negative 2. Negative 4 divided by 2 is negative 2. So we're going to take that negative 2. I know my x value is negative 2 in my vertex, and I'm going to plug it into my equation to solve for y. Y equals negative 2 squared plus 4 times negative 2 minus 5. So negative 2 squared is 4. 4 minus 8 minus 5. So 4 minus 8 is negative 4. Negative 4 minus 5. This y is equal to negative 9. Okay, going to the left. Negative 3, negative 4, negative 5, negative 1, 0, 1. Okay, if you recall, we do not have to do all of these. You only have to do half of them. So plugging in 3 problems, 3 x values will get you all 6 of these missing x values. So let's do the easiest one first, because we know if we created this table correctly, these answers, little rainbow, will all be the same. So let's plug in 0 and get the answer here and here. So if we plug in 0, mental math tells us that the answer is going to be negative, or the y value, sorry, not the answer. The y value is going to be negative 5, which means that this y value is also negative 5. Let's do the other easy one by plugging in 1. So 1 plus 4 is 1 plus 4 is 5. 5 minus 5 is 0. So that means this is going to be 0. And let's plug in negative 1. Negative 1 squared is 1. Minus 4 is negative 3. Negative 3 minus 5 is negative 8. So look at that. The daunting task of filling in this table was just completed real quick using mental math and some strategies to make you see that those numbers are the same, because this is a reflection. The axis of symmetry cuts it in half, and the other half of the parabola is reflected. So let's graph this first. We've got negative 2, negative 9. Let's speed it up while I graph. Negative 1, 2, negative 1. Oh my god. 2, 3, 4, 5, 6. God, it's getting harder and harder to count on these tiny little boxes. So that's negative 2, negative 9. Here's our vertex. If we forgot, let me label it for you. Okay, so here's that. And then we're going to do negative 3, negative 8. So I know I'm going over 1 and up 1. Over 1, up 1. And then we graph that. 0, negative 5. So this is negative 8. Negative 7, 6, 5. And then I want 1, 0. And I also want 1, 2, 1, 2. And then over here to be 0. All right, so here's our graph. This was not stretched or compressed because remember there's no A, and it's not reflected because this is a pretty darn perfect parabola, if I do say so myself. Except for this little part right here. But we're going to ignore that. That is almost perfect. Wow, I'm impressed. Okay, anyways, here's our parabola. And our goal was not to say just graph, because that's what we did in the first couple of lessons of this packet. Now our task is to find the solution. So, well, we just found out what a solution is. A solution is a root, a 0, a solution, duh, or an x-intercept. X-intercept. So I'm looking at my graph, and here's the x-axis, right? Where does this graph intercept it? Oh my god, at this point and at this point. And those would be my zeros. So the way that we write this is we put our solutions in what they always like to call curly braces. Basically just fancy brackets, fancy parentheses. So our x-intercept here is at negative 5 and 1. So the answers to this, and oh my gosh, look. The x-intercept is when y is 0. So hopefully we're connecting a few dots here. So this is my root and my root. Now every question I'm going to call it something new so you can get the hint that all those words mean the same thing. Again, x-intercepts, where y equals 0, where the parabola crosses the x-axis. All right, let's do the same thing here. Let's get the vertex. X equals negative, why did I not write an x? Hello. X equals negative b, so b is already negative, so that means 2 over 2 times 1, which is 1. So we know our x value of our vertex is going to be 1. So let's plug in 1. Maybe we can do it mentally. 1 minus 2 is negative 1. Negative 1 plus 1. Oh my god, negative 1 plus 1 is 0. All right, guys, let's use our common sense. If a vertex is at 1, 0, oh my gosh, I'm seeing double. 1, 0, there we go. Could anything possibly happen for this parabola to come back and hit another part of this vertex? Hopefully your answer is no, because when I told you over here, in order for a graph to be on the x-axis, it will have one solution, or in order for it to have one solution, the vertex only will be on the x-axis. And look, that's what we have here. This, is also our 0. So I can highlight this and tell you that this special point is not only our vertex, but it's also our 0, and this one's only going to have one solution because it's not going to hit the x-axis again. You like my curly braces? Oh my god. So not for fun, but for not fun, we're going to go, I'm sorry, we have to graph it. We have to graph it. I don't want to. Let's fill in this one. Let's just fill in this. If we do 0, we get 1. And if we get this one, obviously it's going to be 1. So 0, 1. Okay. Let's mental math plug in 3. 3 squared is 9. Minus 6 is 3. Plus 1 is 4. Let's do 4. 16 minus 8 is 8. Plus 1 is 9. That wasn't so bad. Our mental math skills are getting better. I know mine are. Hopefully yours are. Negative 1, 1, 2, 3, 4. And then that means that 1, 2, 1, 2 is going to be here. And then 9 should be 1 less than the very top. Okay, if we use our logic, guys, it's not that bad to graph. That didn't take us that long. Okay, so once again, I'm going to circle my 0. I'm going to highlight my x-axis for you just to hit the point home that a 0 is where the point or the parabola crosses the x-axis. Okay, what do we know off the bat about this equation? Hopefully you said that it's going to be opening down. If you did, you're correct. Good job. High five. But not really. Corona. So negative b, negative 2, x equals negative 2 over 2 times negative 1 equals negative 2 over negative, oh my god, negative 2 over negative 2, which equals 1. So our x value of our vertex is going to be 1. We're going to plug in 1 to get our y value. So negative 1, let's just plug it in for fun. Okay, so negative 1 plus 2 minus 3. Negative 1 plus 2 is 1. 1 minus 3 is negative 2. So here's our vertex. 1, 0, negative 1, negative 2, 2, 3, 4. Ugh, okay. So mental math again. If we plug in 0, this is going to be fun. 0 gives us negative 3, which also would give us negative 3 here. If we plug in negative 1, this is negative 1 minus 2 is negative 3 minus 3 is negative 6. If we plug in negative 2, that's 4. Negative 4 minus 4 is negative 8 minus 3, negative 11. We can't even put that one on this graph. What in tarnation? Okay, so what do we notice about this table? What do we notice about the graph? Well, we didn't graph it yet, but what do we notice about the table? The table tells us that I don't see any zeros here. Let's graph it and see if that's correct. So 1, negative 2, 1, negative 1, 2, and it opens down. Kind of hints at the fact that it's not going to come back up in some weird way and cross the x-axis. So this one, our answer because again, we want zeros, solutions, roots is no solution. I'm going to skip graphing this one just because we filled out the table. We already figured out that there are no zeros. This is no solution. I'm trying to train you to be better thinkers. So if I know that this opens downward because of this negative, and it's already below the x-axis, it's not going to curve back up and cross it. It's already below. So a quadratic or a parabola does not work like that. So we won't, excuse me, God, it will not have any solutions here. So this has no x-intercepts. And from what we know in the beginning, the word solution and x-intercept in terms of quadratic means the same exact thing, so it didn't really make sense for me to write that. Moving on because I failed. All right, we've got 3 more to find, then I've got to teach you about the word discriminant. Okay, so again, negative x equals negative 10, so basically 10 over 2. X is going to be equal to 5. Okay, so y equals 25 minus 50 plus 16. So negative 25 plus 16, what does that equal, guys? What's 25 minus 16? I think it's negative 9. Yeah, it's negative 9. So here's the vertex. This parabola is opening up. Okay, so let's figure out the rest. So we've got 4, 3, 2, and then 6, 7, 8. Geez, high numbers. Okay, so the vertex is over here somewhere. So negative 1, 2, 3, 4, 5. And then this is going to be it. 5, negative 9, opening up. So we know it's gonna have 2 solutions. We got to figure out where they're going to be. Okay. Hopefully we'll get lucky and hit them before. So let's plug in 2, just because. Let's plug in 2. 4 minus 20 is negative 16 plus 6. Look at that. Your teacher is the best. We found our 2 zeros. So 2 0 and 8 0. 2, this is 5, 6, 7, 8. Honestly, I don't want to say I don't care if you graph the rest. If you want to, you're a better person than I am right now. But we just found our zeros. So we know our answers, and solutions are x values, by the way, just in case you weren't aware. So our solutions are 2 and 8. So this is basically what x values make your y value 0, and that answer would be 2 and 8. We can see that over here. We got our 2 intercepts. That's that. If you want to fill in the rest of the table, be my guest, all right? Number 5. So again, there's no b, so that means x equals 0 over 2 times negative 1 equals 0. Okay, plug in 0, we get 9. Here's our vertex. This graph is opening downward. So 0, 9 opening downward, guys. Do we already know or do we already know? We're smart. We know that our answer is no solution because common sense tells us, oh wait, sorry. I don't have common sense, clearly. It's positive 9, Miss Dry. I'm going insane. It's positive 9. So forget everything that I just said. We still have to do this. Negative 1, negative 2, negative 3, 1, 2, 3. Okay. All the way to the top, opening down. So it's clearly going to have 2 solutions. I'm really sorry. That was embarrassing. 2 solutions for this graph. So let's try to mental math it. Plug in 1. Negative 1 plus 9 is 8. This is 8. Let's plug in 3. 3 squared is 9. Negative 9 plus 9. There we go. That's our 0. And then we can even do 2. This is going to give us 5. Okay. Let's graph our zeros. Negative 3, 0. Negative 1, 2, 3. And positive 1, 2, 3. And then we've got other things nearby. Negative 1, 8. Negative 2, 8, 7, 6, 5. Didn't take that long. That was crazy if I went with what I was thinking before. So here are our answers. These are our solutions. I forgot to write this over here. This is our root. This is our root. This is our 0. This is our 0. Again, I'm writing them all in different words to let you know that they all mean the same thing. So answer, I can't believe I wrote no solution. -3 and 3. Okay, this one's opening down again. So let's do our axis of symmetry, -6 over 2 times -3, which gives us -6 over -6, which is 1. Let's plug in 1. 1 squared is 1 times -3 plus 6 is 3. So our vertex is 1, 3. Okay, 0, -1, -2, 2, 3, 4. Let's plug in 0, we get 0. Oh, so that means if we plug in 2, which should be 4 times -3. So if we plugged in 2, y equals -3 times 2 squared plus 6 times 2. We would get -12 plus 12 equals 0. We found our zeros. These are our solutions. Okay, if you want to plug in 3, you can plug in 3. 3 squared is 9 times -3, -27, plus -27 plus 18. That would give you -9, I think. 2, we have 4. If you plug in -2, you have 4, -12, minus 12, -24. Okay, this one's very narrow because look, the factor of a is -3. So let's graph our vertex. 1, 1, 2, 3. It's going down. We're going to go with 0, 0, and 1, 2, 0. Do you see how narrow it is? And then we're going to also graph 3, -9, and we'll graph -1, -9, and call it a day. So our answers for this problem were 0 and 2. Those were our x-intercepts. All right. Now, last thing I need to show you today, and if you are good at math, not math, like plugging things in, like algebraic, plugging in, solving math, then you're good. So the discriminant is something that you're going to see. It's part of the quadratic formula. And the formula of the discriminant is d equals b squared minus 4ac. In order to use the discriminant, so what does the discriminant do? The discriminant tells you right off the bat how many solutions a quadratic equation has. So if we were able to know this before we did all this graphing, we wouldn't even need to know how many they were. You saw how we like kind of guessed and checked a little bit. This tells us the number of solutions. So if D, meaning what you get when you plug in B, A, and C, is greater than 0, there are 2 solutions. If D is 0, there is 1. If D is less than 0, there are no solutions. So we're going to go with the discriminant. We're going to label A, B, and C for all the problems that we're going to do, and then calculate the discriminant to tell us, oh, well, this one has 2 solutions, this one has 1 solution, whatever, yada, 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 and that's that. All right, so in number 7, A equals 1, B equals 5, C equals 4. We're going to need that to plug it in. So the discriminant equals 5 squared minus 4 times 1 times 4. So 25 minus 16 equals 9. So what does this 9 tell you? Well, D is 9. Is 9 greater than 0? Yes, there are 2 solutions to this problem. Obviously, this doesn't tell you how to find them, but it tells you the number of them. Okay, A over here, 1, B equals negative 3, C equals 10. So D is equal to B squared, so negative 3 squared minus 4 times 1 times 10. So this gives us 9 minus 40. Well, 9 minus 40 is a negative number. This equals negative 36. So if D is a negative number, what does that mean? That means it's less than 0. This one has no solution. A is 1, B is 10, C is 25. D equals B, so 10 squared minus 4 times 1 times 25. D is equal to 100 minus 100. D equals 0. If D equals 0, there is one solution. Number 10, A equals 2, B equals negative 4, C equals negative 3. D equals B squared, so negative 4 squared minus 4 times 2 times negative 3. Okay, so 16. Negative 4 times 2 is negative 8 times negative 3 is positive 24. Obviously, this is a positive number, so D is going to be greater than 0. D equals 40 in this case. That means it's going to have two solutions. Okay, number 11, A equals 4, B equals negative 12, C equals 9. So B squared, which is negative 12, minus 4 times 9. Yuck. Okay, D equals 144 minus, we're going to do 36 times 4. 12, 34. Oh, 144. I knew that was it. D equals 0. So if it equals 0, that means that there is only one solution. Last one. A equals negative 3. B equals 5. C equals negative 8. So we have 5 squared minus 4 times negative 3 times negative 8. So 25, it's going to be minus because we have 3 negatives. So 24 times 4, that's going to be 96. We know it's going to be a negative number. I don't feel like doing the math right now, but it's going to have 0 solutions because it is a negative number. Negative is less than 0, 0 solutions. I know you're tired of hearing me talk. I'm tired of talking. So the discriminant is very useful in order to determine the number of solutions. Use the discriminant because the discriminant determines the number of solutions a quadratic has. Okay, that's all for today. Ta-ta. See you soon. Carry on. Farewell. Bye.